And so we have the sine of an angle divided by 2 is equal to, and the formula is plus or minus the square root of, it's 1 minus the cosine of an angle divided by 2. That formula is on your sheet. Obviously, that sheet of formulas, you get to have that on the test. I don't make you memorize them. Although, again, if you would like the opportunity to just memorize them, you sure can. Challenge that maybe you want to accept or not. It's up to you. Cosine, we're going to do cosine of an angle divided by 2 is equal to plus or minus. And it's very similar to this. It just changes. Instead of a 1 minus, it's a 1 plus cosine of the angle divided by 2. And our final formula for tangent, tangent of an angle divided by 2 is equal to, you have two options. You could choose 1 minus cosine of the angle divided by sine of the angle, or you could choose sine of the angle divided by 1 plus cosine of the angle. I typically like to choose this option right here because it's only sine in the denominator as opposed to 1 plus cosine. I think that having one item in the denominator makes it a little bit easier. Turn to your notes and let's find where those are so everybody can see exactly where they're located. This is what you're going to look at when you're taking your test. Notice we did the power reducing formulas yesterday. And you actually manipulate these power reducing formulas to come up with our half angle formulas. I didn't show you that, but we just get these straight from those. As you can see that there's a square root involved and some things like that. Okay. Everybody got it? Okay, let's give it a shot. So our first example, we're going to look at the cosine of 15. Now we want to find the exact value. So if you just type 15 into your calculator and press cosine, I will give you 0 credit for that. When it says exact value, you want to see you use the formula and represent it as a radical if need be. Before we did the cosine of 45 minus 30. So you could use a sum and difference formula, which we practiced that the other day, and you're good at that. But today we want to use a half angle formula. So the only question is, what angle do you divide in half to get 15? 30. So 30 becomes our angle of choice. So if you look at your formula, it's the angle that you're choosing to divide by 2 that goes in for this angle spot right there. Sometimes people put a 15 in for the angle because we're trying to find cosine of 15. Again, it's the angle you're dividing by 2 that goes in there. So we're going to keep that in mind. And this is equal to, let's get the plus or minus out of the way. Notice that it says plus or minus right here. That only means that you have to decide if the end value is going to be positive or negative. So the cosine of 15, which quadrant is 15 degrees in? And is cosine positive or negative in the first quadrant? Positive. It is positive. So we know the answer is going to be positive. That's all the plus or minus means. You need to make that choice. So we have positive square root of, and I have 1 minus what?
Cosine of 30.
Cosine of 30 divided by 2. As we work to simplify this, we want an exact value for the cosine of 30. Oh yeah, I'm sorry. Yeah. The same. I didn't make that mistake first hour, but I did that same thing last hour. Nope. What is the exact value for cosine of 30? 30 degrees, cosine.
Square root of 3 over 2.
Square root of 3 over 2. Yep. So that's our value that we choose right off that unit circle. So I have the square root of 1 plus the root of 3 over 2, all over 2. At this point, it is no longer a trigonometry problem. It's just a college algebra problem, right? We're just simplifying a complex fraction. Notice you do have a radical underneath the radical. That's allowed in mathematics. A complex radical is okay, but a complex fraction is not. So I'm going to change this 1 to a 2 over 2. So I have one fraction in the top. This will be 2 plus the square root of 3 over, what's my new denominator? 2, all over, and then I have 2 over 1. Notice I have the radical, so it's encompassing the entire fraction. Some people just write it for the top and they forget about the bottom, but right now the radical is over the entire fraction. Now I want to simplify my complex fraction, so I'm going to multiply by that reciprocal. So times 1 over 2. And notice I get the square root of, in the top we have 2 plus the root of 3. And in the bottom we have 4. I can't take the square root of the top. I just get the square root of 2 plus the root of 3. And in the bottom, the square root of 4 is 2. And that's the exact value. Again, it looks odd to put a radical underneath the radical, but that's acceptable. Not too bad, right? Okay, we'll get to the next one. You might have a chance to finish your assignment in class. We're going to skip the sine of pi over 8. I'm going to change that. I didn't like it. So we are going to do the tangent of 7 pi over 8. So we'll do a tangent problem. I think that'll help you as you get to your assignment. You can see one of those as well. First thing I want to do is I want to convert that 7 pi over 8 to degrees. How do I convert 7 pi over 8 into a degree? What do I multiply by? 180 over pi. Let's somebody calculate that out and tell us what 7 times 180 divided by 8 is.
157.5.
Yeah, so we're wondering the exact value of tangent of 157.5 degrees. Okay? Exact value of tangent of 157.5 degrees. So there's not a sum and difference formula that's going to work, right? Like this last one, you're like, okay, cosine of 15, we've seen that before. We've used a sum and difference formula. Here, there's no sum and difference formula that works. We have to use a half angle formula. What is the angle you divide in half to get 157.5? Yeah, 315. So we have 315 degrees over 2. I have a choice as to which formula I would like to use. I can use this first one or the second one. I do like this first one. Again, it's because there's just one term in the denominator. I like that it's just sine. And so this becomes 1 minus the cosine of 315 divided by the sine of 315. Which quadrant? Fourth. Is cosine positive or negative in the fourth quadrant?
Negative.
Cosine is positive in the fourth quadrant. 315 degrees, that's going to make that 45-degree reference angle. So I have 1 minus, and if it's a 45, what are we going to have for a terminal point? For a 2 over 2. Again, let's say it was 225 and cosine was negative, then we would have to switch that sign to 1 plus. Okay? And then the sine of 315 is the sine of 315 positive or negative? Negative. So we have a negative root of 2 over 2 in the denominator. So the trigonometry is really done. Now we're just doing with an algebra problem, simplifying this complex fraction. And so I'm going to create one fraction at the top. I'm going to change that 1 to a 2 over 2. So I have 2 minus the root of 2 over 2, all divided by negative root of 2 over 2. A lot of 2's in this problem. As I multiply by the reciprocal, the 2's do cancel. And I get 2 minus the root of 2 over negative root of 2. So can people see again why I like to use that first formula? Because I just end up with the square root of 2. That way I don't have something like 1 minus the root of 2 or something like that. So how do I finish this off? What do I need to do? Yeah, I get rid of that square root by multiplying the top and bottom by the root of 2. When you're multiplying the top by the root of 2, make sure you distribute it to both parts of the numerator. Both terms want that square root of 2. And so we get root of 2 times 2 is 2 roots of 2. Oh, when you multiply the top and bottom, you could multiply by a negative, but you don't have to. So I'll do it without so you can see it, but you sure could if you wanted to. So root of 2 times 2 minus, what is the root of 2 times the root of 2? 2 over, and then negative root of 2 times root of 2 is negative 2. Now I could deal with that negative by, say, factoring a negative 2 out of the top. If we factor a negative 2 out of the top, notice how this negative 2 will turn to a positive 1. And then the 2 roots of 2 will turn to a negative root of 2. And they'll all be over negative 2. Those cancel, so I have 1 minus the root of 2 is the final answer. Let's check the reasonableness of our answer. I have 1 minus the root of 2. Is 1 minus the root of 2 a positive number or a negative number? It is a negative number. And if you look at our original problem, we said the tangent of 157 degrees, 157 is in the second quadrant. Is tangent positive or negative over there? It is negative. So again, those are the nice checks that you can do to just see if your answer is reasonable. But yeah, there you go. So you have a cosine example and you have a tangent example. Go ahead and take out your homework. Yep, good job. So you see this half angle one. There are just 6 problems on the front, okay? And tomorrow we're going to be looking at those half or sum to product and product to sum formulas. Those are not very tough, okay? I would say it's the easiest ones of all, and that will finish off where we're at, okay? I'm going to get you a study guide by Friday that you can start looking at, and I'll show you the schedule as well for kind of the next week, so to speak. But you should really have most everything in front of you. You guys have done a really good job. I know that this test is going to be a little bit more challenging than the others, but because you guys have worked really hard this semester, we've got a little bit of time here before the quarter's over where, we don't have to rush. So what we've done in the last 4 days, last year had to do in 2 days. Because we were behind. Number one, things took us longer. And second of all, we had like 3 snow days last year. So that just set us back. So it's a little bit tougher. We were able to kind of, I guess, take it bit by bit. So answer key is posted up here if you want to check stuff. And that's it. So go ahead.
And what day?